Exponential functions. When an unknown is the power of a number or a function, it is called an exponential function. For example, we have 2 raised to the power of x. So this is an exponential function. It has a base and a power, and the power is the unknown. 3 raised to the power of x is another example of an exponential function. So our first example 1, when we have an exponential 2 raised to the power of x equals to 64. How do we solve this? 2 raised to the power of x is an exponential. 64 is not an exponential, and it should be expressed as an exponential function. It should be expressed as an exponential function. So how do we express 64 as an exponential function? 64 must include a base and a power, and the base of 64 must be equal to the base of the unknown. So the base of the unknown here is 2 raised to the power of x. So the base of 64 will be 2. 2 raised to the power of what number will give us 64? That will be 2 raised to the power of 6. So 2 raised to the power of 6 is equals to 64. So the base of 64 is 2, and the base of the unknown here is 2. So when we have similar bases, we eliminate the both of them. So 2, 2 will be left with x equals to 6, which is the power. So the unknown x is equals to 6. This is our answer. So second question, number 2. We have a number 5 raised to the power of x plus 1 equals to 625. So this is an exponential function. This is not an exponential function. So we express this as an exponential function. What do we have? So the base of this number will be 5 automatically, because the base must be similar to the base of the unknown, which is 5 raised to the power of x plus 1. So the base 5 raised to the power of what number will give us 625? That will be 5 raised to the power of 4. 5 raised to the power of 4 will give us 625. So when we have similar bases, we eliminate 5, 5. We'll be left with x plus 1 equals to 4. So when we collect like terms, 1 will cross over to the other side. We'll be left with x. So x is equals to 1. Then the sign will change to -1. Then x is equals to 4 minus 1 is 3. This is our final answer. So that's question number 2. Then number 3. Let's solve number 3 here. We have 4 raised to the power of x equals to 1 divided by 1024. So now we need to take note of the exponential function. This is an exponential function. This is not an exponential function. So this exponential function can be expressed to the lowest base. 4 can be expressed to the lowest base. Unlike 5. 5, this is the lowest base of 5. So we can't express 5 to the lowest base. 2, this is the lowest base of 2. And we can't express it to the lowest base. So 4, we can express 4 to the lowest base. So the lowest base of 4 is 2. 2 raised to the power of 2 will give us 4. But 5, there is no base and power that will give us 5. So 5 is the lowest base. But in 4, there's a base and power that will give us 4. So 2 is the lowest base of 4. Same thing when we have 16x. When we have 16x, the lowest base of 16 is, we have 4 raised to the power of 2. And it can still be simplified to give us 2 raised to the power of 2, 4. So when you have 4 as the base of an exponential and it can be expressed to the lowest base, you express it. If it cannot be expressed, we leave it that way. So 2 raised to the power of 2 give us 4, multiplied by x give us 2x equals to If we apply the negative index as one of the laws of indices, if we apply it here, we have the same thing as 1024 raised to the power of -1. So this same thing as this same thing as this, laws of indices. So this will give us, automatically we have a base of 2. As I said, the base of this number or fraction must be similar to the base of the unknown. So 2 raised to power, what number will give us? Will give us 10. Will give us will give us 1024. That will be 10. 2 raised to power 10 will give us 1024. So here we have similar bases. We eliminate the both of them. We'll be left with 2x equals to 10. So what do we do here? We divide both sides. So we have a negative sign here. So 10 will multiply -1. So 10 multiplied by -1, we have -10. So we divide both sides by 2. 2 cancels 2. X is equals to -10 divided by 2 give us -5. So this is our final answer. Then question number 4. Question number 4. We have 4 raised to the power of x plus 1 equals to 8 raised to the power of x plus 2. So now this is an exponential function, this is also an exponential function, and the base of this exponential can be expressed to the lowest base. So the lowest base of 4 is 2. 2 raised to the power of 2 will give us 4 multiplied by x plus 1 equals to, the lowest base of 8 is 2, and 2 must equate the base of the unknown. So 2 raised to the power of 3 will give us 8 multiplied by x plus 2. So here we have 2. 2 multiplied by x will give us 2x. 2 multiplied by 1 will give us plus 2 equals to 2. 2 multiplied by 3, sorry, this 3. 3 multiplied by x will give us 3x plus 3 multiplied by 2 will give us 6. So when we have similar bases, what do? We eliminate them. Then we'll be left with 2x. 2x plus 2 equals to 3x plus 6. So this will be, when we collect like terms, we have 2x minus, the positive sign here would change to minus, so we have minus 3x equals to 6. Then 2 will cross over to the other side, we have minus 2. So 2x minus 3x will give us, this will give us minus x. So minus x is equals to 6 minus 2 is 4. So we divide both sides by minus. Divide both sides by minus. So take note, there's an invisible one here, but it's not necessary to add it. So 1 cancels, that's minus cancels minus, we're left with x equals to 4 divided by minus, or 4 divided by -1 will give us -4. This is our final answer.